Hello there, Cougar Academy, and welcome to lesson 6.8. Today we're going to be graphing linear inequalities in two variables. So here are some steps for you to follow. Step 1, decide on the type of line to use. We're going to use two different types of line, either a solid line in our graphs, and we use those for if you have greater than or equal to, or less than or equal to, or a dotted line for our graphs if you do not have that equal to sign. So that's the major difference. So like for number 1 here, we have a less than sign, so we're going to use a dotted line, no equal to. Put the line in slope-intercept form, which is already done for us in number 1. Remember that is y equals mx plus b, plus or minus. That helps you graph. Graph the line using y-intercept and slope. So we're going to need to remember some of our graphing skills. You should hopefully remember that 5 is our y-intercept, and that means we're going to plot on the y-axis 5. In front, that is our slope, which is rise over run. So we have a -1 rise, and we're going to go 1 to the right. Or, remember, that is a 1 rise and 1 to the left. Okay, it's either one. If you're ever not sure, you can always use your graphing calculator, and that will also give you an idea as to what direction the graph is going. So it is going down 1 to the right, down 1 to the right, down 1 to the right. Now, we already decided we're going to use a dotted line to connect our points. So that's where it gets a little unique. Just a dotted line right through those the best you can. Okay, could be a little straighter, but that's the idea. Now, the other new thing is you have to shade a solution area. So we are going to either shade above the line, which I like to think that's where you can stand above, or we're going to shade below the line. Okay, so it's a nice idea to kind of get used to this above, below. Above is where you can stand, below is where you wouldn't be able to stand. You're going to shade above the line for greater than or equal to's. And you're going to shade below the line for less than or equal to's. And it has to be in y equals. Okay, so what do we have? We have a less than, which means dotted, and we're going to shade below. So we are actually shading everywhere underneath this graph. Okay, now what that means is all of these coordinates are solutions. Okay, so what I like to recommend is the last step: check your solution area. Don't skip that step. You always want to check. So pick any coordinate point like 0, 0 and check that it works by putting back into the original equation. So we have x and y, which means y is 0. Is that less than -1 times x plus 5? Well, 0 less than 5. Is that true? Yes, which means we shaded in the right spot. Okay, if you were to check a point, say up here, so if we were to check the point 5, 5, you would have 5 less than -1 times 5 plus 5, and 5 less than 5. Okay, -5 plus 5. 5 is not less than 0. So that's why that is not shaded. Okay, so a little clarification on the shading. So everything underneath is where you should shade. Okay, let's look at another one from standard form here. So I would recommend decide what type of line. So a solid line, because we have less than or equal to, and we'll end up shading below, again, because we have less than. Okay, let's get our graphing calculator just to get an idea as to what it looks like without the shading. X minus 3. And if you go to the graph, you should see. Now, y-intercept's at -3. Our slope is -1/4, so up 1 to the left 4 also works. or down 1 to the right 4 also works. Now this time around, you would use a solid line to connect those, okay? A solid line, and once again, we are shading below our graph. So again, above the graph is like where you could stand, but we want to shade below that, okay? So below the graph there. Pick a test point. So if we were to pick the point like -4, -4. Putting that back into the equation, so -4 less than or equal to -1/4 times -4 minus 3. If you were to simplify that, that's asking is -4 less than or equal to 1 minus 3? And -4 is less than or equal to -2. That is true, which means we shaded in the right spot. Okay, so that is graphing with some shading. The next two examples, I will cover those in another video.